Okay, good morning, pre-calcers. This is going to be a lesson on section 3.3. So watch this, and then when you get done, you can start working on your homework. Okay, on this first page, we've got some property of logarithms that you haven't seen yet. And there's three properties that work both for logarithms with a base A or logarithms with base E, which is also natural log. So here's how it goes. It's a lot like exponents. When you're multiplying, it's going to be able to be written separated using addition. So if I separate these, I'll have log base A of U plus log base A of V. It's a lot like exponents when you are multiplying, like x squared times an x to the third. You add the exponents. It's very similar to that. Multiplying expands into addition. Division would expand into subtraction. So we would have log base A of U minus log base A of V. So that's very similar to exponents. The third property says that if you have something to a power of n, you can take that power and bring it down in front and multiply. So we could take n and then multiply by log base A of U. And all of these apply for natural logs. So multiplication will turn into addition. So natural log of U plus natural log of V. Division will turn into subtraction. So natural log of U minus natural log of V. And then again here I can take this exponent, I can bring it down in front. So I'd have n times ln u. Also, they work backwards. So I could take something that is subtraction and put it back together into division. Or if I see addition, I can put them back together as multiplication. Or if I see a number out in front, I can bring it back up as an exponent. So all these properties work forwards and backwards. So I just wanted to show you using this how the different properties work. So for example, I could do log base 2 of 4 times 4, because 4 times 4 is 16. And so multiplication turns into addition when I break it up. So it'd be log base 2 of 4 plus log base 2 of 4. And I can evaluate them separately. 2 to what power equals 4? 2. 2 to what power equals 4? 2. Add them up, you get a 4. Or I could have just done it, straight from the beginning. 2 to what power equals 16? And so it would be a 4. I could have done it that way. Or using the third property, instead of 4 times 4, I could say 4 squared, and I could bring this 2 down in front, so then it would be 2 times log base 2 of 4, and log base 2 of 4 is a 2. So then 2 times 2 is 4. You can think about these problems so many different ways. So if one way is not quite working, you might want to try another. So we're just going to simplify these problems. Now, imagine these are no calculator. Okay, see if you can do these without a calculator. Well, you would get to this problem, let's say this was on a test. You would get to this problem and you go 9 to the 4th. How does she expect me to know what 9 to the 4th is? And then how does she expect me to know what 3 to what power would equal 9 to the 4th? Well, I don't. That's why I want you to learn your properties. So the third property says this number right here can be written down in front. So this can be written as 4 times log base 3 of 9. Now this log base 3 of 9 you should be able to do without a calculator. If we do it over here, log base 3 of 9, what does that equal? 3 to what power equals 9? It's a 2. So log base 3 of 9 is 2. Multiply that by the 4 out in front, and then we get 8. But see, that problem would be a lot harder to do if you didn't know your properties. So these properties you do need to know. Okay, if you come over here to part B, if I try to do these separate and try to ask myself 5 to what power equals 100, that would be tricky, some decimal. And if I try to do 5 to what power equals 4, again, I can't do that in my head. But if I know my properties, subtraction condenses back down into division. So if I condense this back down, it would be log base 5, but then it would be 100 divided by 4. Well, I can do that without a calculator. 100 divided by 4 is 25. This I can do. 5 to what power equals 25? So your answer is a 2. But if you tried to do this problem separately and then subtract, it would be very hard to do without a calculator. So if you ever have a no calculator page and you're thinking to yourself, how does she expect me to do this without a calculator? Then you gotta say, oh, it's a property. Okay, this one, log base 4 of 8 plus log base 4 of 8. Well, 4 to what power equals 8? That's going to be a decimal somewhere between 1 and 2. So don't do them separately. Condense them back together. Addition condenses into multiplication. And 8 times 8 is 64. And now hopefully this is something you can do. 4 to what power equals 64? And it's a 3. Okay? These problems are not solving problems. These problems are just expanding problems. So we're going to use the properties and expand, so they should look bigger or ickier than you start off with. These are currently simplified. We're going to expand them. So just remember, multiplication expands into addition. So we have a 3 times a x times a y squared. All of that will get broken up. So every time you see a multiplication sign, break it up with an addition sign, and you have to write that log base 4 every time. So I have a log base 4 of 3 plus a log base 4 of x plus a log base 4 of y squared. And then again with the third property, if I have an exponent, I can bring it down in front. But it's only going to go down in front of the term with the y because the y was the only thing being squared. So I bring that 2 in front and then have the log base 4 of y. On this problem, I have multiplication and division. So when I expand that, I'll have log base 6 of x squared. Multiplication turns into addition, log base 6 of y to the 4th. And division turns into subtraction, log base 4 of z to the 3rd. And then all of these exponents go down in front. So then we'll end up with a 2 log base 6 of x plus 4 log base 6 of y minus 3 log base 4 of z. This is a cube root. It might be helpful to write it as an exponent. Natural log of x to the 1/3. And then what you could do is just bring that 1/3 down in front. So we'd have a 1/3 natural log of x. Okay, this is a really good type of problem because you can't rely on your calculator very much. So I'm giving you information here. I didn't give you the base, it's just some base a, but log some base a equals 1.609. And log with some base a of 2 equals 0.693. The goal is not for you to figure out what the base is. The goal is for you to use these two to come up with what log base a of 10 would be. So you want to involve 5s and 2s. Well, I know that 5 times 2 is 10, so I could say log base a of 5 times 2, but I'm not going to multiply 1.609 by 0.693. Multiplication expands into addition. So this is log base a of 5 plus log base a of 2. We're not multiplying these two together, we're adding them. Because log base a of 5 is 1.609 and log base a of 2 is 0.693. I would add those up, not multiply. You can figure out what that is on your calculator. Over here, how could I write 8 using 2s or 5s as much as possible? Let's see. Well, 8 is 2 to the 3rd. And I've got division going on, so if I expand that, it would be log base a of 2 to the 3rd minus log base a of a squared. I could bring these exponents down in front. That might be helpful. So I would have 3 log base a of 2 minus 2 log base a of a. All right, well, log base a of 2 is given to us. That's the 0.693. And then log base a of a, let's do that up here. Log base a of a, what does that equal? A to what power equals a? It's a 1. So you can now type this in your calculator. 3 times 0.693 minus 2. Okay, I'm going to stop here and then I'm going to record the second half of the video. So now click the link below this and watch part 2. This only lets me record so much time at a time. So stop this and go to part 2.